The Sky This Month with your host, Dave McDonald.
Welcome to The Sky This Month. I'm your host, Dave McDonald, and the month of May has a great eclipse happening. It's a lunar eclipse, and we're going to talk a lot about that lunar eclipse at the end of the show. Happening also this month on May 14th, Saturday evening, is the statewide astronomy bowl that has been organized by the Belmont High School Astronomy Club and will be hosted by the McAuliffe Shepherd Discovery Center in Concord, New Hampshire. And we thank them for hosting, and we want to give a shout out to the New Hampshire Astronomical Society for donating a prize of a 8-inch Orion Dobsonian telescope. We want to give a shout out to Win Aero, who has donated a whole week of either aviation camp or drone camp for a week in July. And a shout out to the New Hampshire Total Solar Eclipse Task Force for donating a $300 cash prize and a ride in the Eclipse Mobile. So we thank all the participating entities in this statewide astronomy bowl. First up, let's just mention the great lunar eclipse. You can see in the slide right there that the great lunar eclipse is happening May 15th to May 16th, and that is starting like 10:27 p.m. This is Eastern Daylight Time, and it's going to run through the early hours of May 16th, which is a Monday. So Sunday night, May 15th to the early wee hours of Monday morning, May 16th. And as I said, we're going to talk a lot about it. So whether you're seeing this before the eclipse to learn about what you're going to have an opportunity to see, or whether the eclipse has passed and you've seen it or not, hopefully it's going to be clear. And you'll understand a little more about eclipses and lunar eclipses in particular. But one of the great things that we have to offer today is we have a special guest with us, Adam Krznecki, who's no stranger to the Sky This Month, has returned from his second year. His sophomore year is now completed from Clemson. Welcome again, Adam.
Glad to be here as always.
So, quick rundown. What was your sophomore year like? And you're majoring in engineering?
Mechanical engineering, and I'm going to be doing a 5-year master's program in mechanical engineering, and I hope to do some aerospace focus in that as well because, as you can see, I'm a frequent member on the show, so I clearly have an interest in aerospace and astronomical happenings. And in this case, throughout all my high school years and the beginning of college, they always tell us it's not rocket science. Well, this time it actually is. So definitely been a lot of work and a lot of dedication, but it's definitely worth it. I've been able to meet some really nice people and learn a lot of great things.
That's awesome. That's awesome. And so one of my major amazements in terms of human engineering has to do with the Perseverance Rover that we've talked about before that landed on Mars February 18th, 2021. So we're just a couple months over a year from its landing. And Adam, you've done a little research about what it's about and what it's been doing. So give us a Perseverance update.
Absolutely. So obviously, as we discussed on one of the previous shows, the Ingenuity helicopter on Mars has been doing some tests. And along with that, that's kind of been stealing the show, but along with that, this rover, one of the most interesting things of it to me is that it's really the first one to go and look for any sort of clues of life on the Martian planet. And that's sort of one of the reasons of where it was chosen to land. It landed in Jezero crater, as we mentioned before. And as you can see in the top right of this photo, there is a river delta of an ancient river that used to flow into the crater many years ago before this. Let me redo that. There's a river delta that was seen flowing in from the top right corner of the crater. And that is one of the prime locations that scientists believe there may be samples of prehistoric life, even maybe at the bacterial level. And what the rover will actually be doing is taking samples of the rock to go and look at it, and that's what's in the middle of the screen, where those holes are only 150 microns wide and 3 millimeters apart. And it's able to drill in because of the crater into some areas that are pretty exposed at deeper levels that you'd be able to get anywhere else on the planet due to the fact that it is a crater and there's already depth, so you can get to it without drilling.
So that's pretty cool. So we're looking for the clues to life, because apparently there seems to be no question there was a lot of water there at one time.
And one of the interesting things I've heard too is that pretty much anywhere, like on Earth at least, wherever there's water, there's life. They haven't been able to find a place without life where there's water. So if there's clues of water before on Mars, it's just whether a question of if it had enough time to get to the stage of life. So that's why they're looking at such a small scale and with so much details, because it could have even been microscopic or just the formations of life, but they're mainly looking for samples of rock that have processes done to them that they can deem to not be possible to be done through geologic circumstances.
Right. And these are holes that Perseverance drilled.
Exactly.
Nice. Okay. Well, speaking of life, someday we hope to send some life, some human beings to Mars. And one of the things that human beings need is oxygen to breathe, for sure, and then also for rocket fuel if you want to think about coming back to Earth. So we have a cool instrument here called MOXIE that's on Perseverance, and maybe Adam, you could take us through that.
Totally. One of the other shows that we went over the instruments of the Mars Perseverance Rover. This was one of the ones mentioned, and it's the Mars Oxygen In Situ Resource Utilization Experiment. Quite a mouthful, but it's a pretty important instrument in my mind because it's knocking off two major tasks, and just sort of a proof of concept for this is that it is able to take the CO2 in the Martian atmosphere, which is the major gas composing the majority of the atmosphere there, and it can actually harvest oxygen out of the atmosphere. And that's really important to do because it can use that oxygen for astronauts to use with any sort of mission to Mars where they can be living there for an extended period of time, or just for rocket fuel to help with the return trip of either astronauts or other sample collections, etc., that are on the Martian surface. And this is due to the fact that Mars does have a pretty decent gravity well compared to other bodies like the Moon or other asteroid samples that have been collected by NASA and other agencies, that it is actually kind of difficult to leave again. Like leaving Earth requires a lot of energy because of the high escape velocity relative to other bodies in the solar system. So being able to build some of your fuel on the planet itself is pretty huge, because then you don't have to carry it there, and that's obviously going to take a lot of energy to get there. So definitely stepping stones to being able to do some larger missions to Mars and possibly with humans. And one more side note on the Perseverance rover itself is that they actually used microphones on it this time to get sort of a feel of what it would sound like one day when people actually get to go there. And you can look up online, you'll be able to find the files pretty easily. You can just type in wind sound on Mars Perseverance, and it'll come up, and it's a very eerie feel. It almost feels as if that it was taken on Mars.
The son of a gun.
Yeah.
You never know. And they've used MOXIE, so they have actually created some, or I should say,
Gathered.
that's a good word.
Yeah,
Gathered.
right.
Gathered some oxygen out of the CO2, which is the main atmospheric property of Mars. So CO2, I think it's about 95% CO2 in the atmosphere, but it's really thin because even though 75% of the atmosphere is CO2, the entire atmosphere is only about 1% of the density of our atmosphere on Earth. So it's high percentage CO2, but the whole atmosphere itself doesn't have a lot of molecules, about 1/100th of what we have here on Earth. So it takes a lot of work to get a little bit of oxygen.
Exactly.
So the next in the news, one of the big things, in addition to Perseverance still working up there on Mars, is this image here. There's 3 images here, and we've talked about, like last month, what we had a key speaker, Dr. Feinberg, talked about the James Webb Space Telescope, and so you have an update of what's the latest and the greatest with James Webb, Adam.
So James Webb has successfully made it to its final location, which is the L2 Lagrange Point. And what a Lagrange point is sort of a gravitational well that something can orbit in space in a solar system that's not exactly around another body. So it's kind of an interesting idea, and if you're not unfamiliar with the topic, then maybe you should look it up and find out some really cool things about how gravity works. But in this case, it's in line with the sun past Earth, and a little bit out past Earth in line with the sun. I forget the exact distance. I think it's about 1.5 million miles away.
It's close to a million.
Close to a million, okay. And it's basically going to hang out there, and they're doing that on purpose to get further away from the sun, and so that this James Webb telescope is an infrared telescope, so it requires really cold temperatures, and that's part of, if you've seen, the actual telescope itself has some pretty serious solar shades that shield itself from the radiation of the sun, and it also has a pretty intense cooling system on it using liquid hydrogen, I believe. And with that, it's able to cool down its sensors enough that it can pick up even the faintest of radiation in the form of infrared from anywhere in the galaxy and solar system too, depending on where they're looking.
So what are we looking at here, these three images?
These three images are the sort of the progression of infrared telescopes over time. Two other well-known infrared telescopes that have been in action for quite some time are the WISE telescope and the Spitzer telescope, and they're actually all pointed at the same couple of stars in this photo. And once James Webb telescope actually got all of its mirrors aligned and focused in, the image on the right in this slide is what it was able to capture. And as you can see, compared to the other photos of the other infrared telescopes that have been in action, it's pretty unbelievable how much detail there is in this photo. And one little side note, as you can see, the what was that again? The solar burst?
Starburst.
The starburst.
Yeah.
As you can see again, the starburst in this photo, it actually has 8 flares coming off of it, and that's due to all the separate panels of the James Webb Space Telescope that are unique in comparison to a lot of other telescopes that usually have one single mirror.
So it's a great instrument, and we're hoping that in June there'll be some, it'll start doing its science work. So it's kind of preliminaries all now, making sure that everything is working right, that the mirrors and the instruments are all calibrated correctly. So, and it looks like, that's an amazing image.
And again, the choice for infrared in this telescope was to be able to see further back into time by looking at the furthest reaches of what we can see in the observable universe, because due to the expansion of the universe, many things become redshifted the further they are away from Earth due to the Doppler effect. So by looking even below red on the visible spectrum into the infrared category of light, James Webb hopes to be able to see even further back in time and give us more clues about the formation of our universe.
And another nice thing about infrared is it cuts through dust.
Exactly. That's another great thing about
it.
Which
is important. Yeah, so that's awesome stuff. Coming back down to Earth in your backyard, what are we looking at here, Adam?
So later in the month, especially if you're an early riser, actually only if you're an early riser, you can get up and see quite the gathering of planets in the sky in the east, southeast direction. You can see Venus, Jupiter, Mars, and Saturn all together, which would be quite the spectacle if you felt up to getting up and going out and looking in the morning with a telescope or even just binoculars. You could see all of these, and definitely something cool to look at. And I have to always make a note whenever Saturn's in the sky and visible you really got to take a look at that through a telescope if you never have, because it's really spectacular.
And the nice thing about Saturn in this lineup here is that Saturn will rise first.
Exactly.
So the sky will be darker, which is nice to have that contrast when you're looking at Saturn through even binoculars. But as you said, Adam, a telescope, it's amazing. Every time that we go out and look through a telescope, everybody's first view of Saturn through a telescope is that painted on the end of the lens? Is that painted? Is that real? It's really crazy. And then you can see the moon down here, which is working its way back towards the sun. It's in the waning crescent stage, and so again, very pretty. So I think, Adam, we're somewhere around like May 24, 25, 26, 27.
Yeah, 25th was this photo.
And this one is on the 25th. So great views of the moon. And stay tuned for later on in the show, I'm going to show you something amazing that's going to be happening on May 29th, keep your eye on Jupiter and Mars. Jupiter is shining at about a negative 2.2 magnitude, and Mars is 0.7. 0.7 is pretty bright. I mean, it's brighter than a magnitude 1 star, but compared to Jupiter of a negative 2.2, which is brighter than the brightest star in the night sky, it's quite a contrast. And Mars does have a reddish color. Jupiter is sporting a disk of 37 seconds of arc, and Mars just 6 seconds of arc. So there's also quite a dynamic size difference. Again, if you get a chance to look at it through a telescope, they'll be in the same field of view during the day before the 29th and the 30th of May. Don't miss that opportunity. I'm going to show you more about that at the end of the show. So that's great, Adam. Thank you so much for being part of our show once again.
Absolutely.
It's always great having you here, and thanks for the update on Perseverance and James Webb and letting us know what's going on in the morning sky that we can enjoy these planets.
Absolutely. Pleasure being here.
Thanks again, Adam. And so I understand that you're going to be going off to an internship this summer.
Yes, I am.
Do you know where? Oh, well,
Yeah.
obviously you know
Yes,
where.
I do know where. It's going to be at Crane Co. in Spartanburg, South Carolina. I'm going to be a junior manufacturing engineering intern there,
Right.
which will be a little upgrade over coming back home to mow lawns. So
Right.
know a little bit more engineering now, so we're going to do that and hopefully get somewhere later. I was thinking doing something in the aerospace field after that, which would be really exciting because it'd be like a dream come true.
And I believe it will come true for you.
Thank you very
Best
much.
of luck. You're welcome. Okay, so we're going to take a look at more detail about this great lunar eclipse coming up and the night sky. So that was great having Adam back on the show. Sounds like he had a great year at school and is going to have a great internship this summer. Coming up, the middle of May, May 15th to May 16th is the great lunar eclipse. So what makes it so great? This next slide gives us some idea of what is going to be making this so great. And the moon is entering the penumbra, okay? And that's, you know, it's almost really difficult to see that part because it's in a very, very light, shadowy. But the partial eclipse, this is what you start to really see the shadow of Earth cover the moon, which starts at 2:28 UT, which is universal time. I'm going to explain a little bit about what universal time means in a moment. But on Eastern Daylight Time, that's 10:28 in the evening. So starts kind of late. And then we get into the totalness, the umbra, which is going to begin at 3:29 universal time. And so that's basically an hour later, and totality is going to begin. And then the mid eclipse will be at 12:12, right? 12 minutes after midnight. So now we are at May 16th. That's the deepest part of the eclipse. And then we work our way. The total eclipse is going to end at 4:54. So we're talking about 42 minutes later is when it's going to start to end, and the partial eclipse will continue and continue until about 1:56 a.m. So just about 2 o'clock in the morning is when the whole thing will be done. But the moon will continue to be into the penumbra part of Earth's shadow, which again is a very light, almost hard to notice shadow. But what makes this so great, I mean, we've seen lunar eclipses before and we'll see them again. Hopefully it'll be clear wherever you are for May 15th, late night, early morning, May 16th. But you see, you have 85 minutes of totality, just shy of 85 minutes of totality. It rounds to 85 minutes of totality, which is an amazingly long period of totality for a lunar eclipse. And this is related to the geometry, which I'm going to talk about in just a little bit. But I want to talk a little bit about the time. So let's go to the next slide. And we've got the same progression of the moon happening here, but we want to talk about the moon and where it's going, where it's come in relationship to these times here. So universal, UTC, is what we call universal time coordinated. Used to be GMT is what we called these things. GMT, Greenwich Mean Time, which is still a thing, but it got confusing because Greenwich is actually a place. You know, it's a town on the outskirts of London. I had the opportunity to be there. I'm going to show you a picture in just a little bit. I had the opportunity to be there in Greenwich at the Royal Observatory where they keep the official time of the world. And Greenwich has a different time than GMT. So they decided that, well, you know what? Since Greenwich Mean Time was supposed to be universal world time, but the town itself is an hour different, it's confusing. So they decided, well, we're going to call this Universal Time Coordinated, or UTC time. Sometimes you just see it as UT. So UTC, Universal Time Coordinated, that is the official time of the world. And from there, you have your time zones develop from there. So we, in the Eastern Daylight Time on the eastern seaboard of the United States, and I know some of you are watching the show elsewhere in the United States, which is awesome, but we're 4 hours, we subtract 4 hours because the universal time is 4 hours ahead of our time when we're in Eastern Daylight Time. And then you may hear, if you are a pilot, you hear about Zulu time. And Zulu time, or Z, is the same thing. So they all mean the same thing, but GMT, or Greenwich Mean Time, we're just not used that much anymore to avoid confusion. So typically we use UTC or UT, Universal Time Coordinated, or Zulu, and this is the time on the prime meridian. I can't wait to show you this next slide. I told you I went to London, and here I am on the prime meridian. That is, my left foot is in the eastern hemisphere, my right foot is in the western hemisphere, and that is the line of 0 longitude, 0 minutes, 0 seconds. Isn't that crazy? And we have a photo bomber decided to be part of my picture. Obviously, I wasn't looking, so I didn't know, and whoever was snapping the picture didn't seem to care. So very, very cool. Next, we want to talk about, well, you know, what exactly makes a lunar eclipse? Well, needless to say, we have to have the sun, and we have Earth, and we have the moon. But just to differentiate, a solar eclipse happens when the moon comes between Earth and the sun. So the moon is in a phase we call the new moon, and it blocks the light from the sun. If it's directly lined up, if it's on the proper node, it will block the sun. And if it blocks it totally, we call it a total solar eclipse. If it blocks it partially because the moon is further away and it's not quite large enough to block the sun, we call it an annular eclipse, and then there can be partial eclipse. And just as a quick note, mark your calendars for April 8th, 2024. It's a Monday, April 8th, 2024. In New Hampshire, we're going to experience a full total solar eclipse up in Coos County. Back to the lunar eclipse, you can see for a lunar eclipse, the moon is on the other side of Earth, and so basically it's Earth that is blocking the light from the sun. We can go to the next slide and talk about that just a little more specifically. Earth is blocking the light from the sun. The sun is over here, and the Earth, we're going to have block the light from the sun, and you can see the moon loses its light when the moon passes into the shadow of Earth. So next slide, we see a little bit of the geometry that's happening here. So take a peek at this. You can see where the sun is, obviously. The sun is right down here, and Earth's orbit is coming around. So you see Earth is coming around with its orbit And the motion of Earth is in this direction because Earth goes around the sun counterclockwise, and the moon goes around Earth counterclockwise in this direction. So as Earth moves around the sun, the orbit of Earth, the moon is moving around Earth, and when the moon lines up so it's in the shadow of Earth, then we have that lunar eclipse. And it's in this period in here, and again, this depends on the geometry of how far away the moon is from Earth, and we have this time the longest total lunar eclipse, 85 minutes, which is really, really awesome. So that's a little bit of geometry of what's happening with the eclipse. Next slide, just why is it blood? Why do we call it a blood moon? And we call it a blood moon because look at Earth. Earth has an atmosphere, and right here, the atmosphere that you see around the moon, the atmosphere around Earth, you've seen red skies at night, you've seen red skies in the morning, and what's happening is the light from the sun is coming through the atmosphere of Earth, and you're seeing all the sunrises and all the sunsets on Earth being reflected onto the moon. And that's why we see this bloody red moon here, is because the light is coming from the sun through the atmosphere of Earth, and all the sunrises and sunsets on Earth, that color is shining and being reflected back from the moon. And that's why it's so bloody red. Next slide gives us the details on, again, where we can see this. And so over here is a map, and what you see in the lighter area is where we're going to be able to see the total solar eclipse. And the timing, once again, is here, and the moon enters into Earth's shadow, and it's going to be hanging out for 85 minutes in the deepest part of the shadow, and what we call the deep part of or the Mid Eclipse point is at 12 minutes after midnight. It's going to be right here. And so you can see the moon is kind of very close. The shadow is pretty close to the middle of where it could be, and that's why we have this longer eclipse. And so we don't want you to miss it. May 2022, the late night of May 15th, early morning of May 16th, the total lunar eclipse, the blood moon, is coming your way. Don't miss it. Next, let's talk about some stars and some constellations that you can see in the night sky. So first off, let me point to you the Big Dipper. Can you see the Big Dipper? Most of it is here. You can see the handle of the Big Dipper right here. And the handle of the Big Dipper points to a star. If you follow the arc, and this is 10 o'clock, and I've just chosen a week later, so this is May 22nd, 10 o'clock at night, so the sky is nice and dark. The Big Dipper is pretty much overhead. If you look overhead a little bit towards the north, you'll find the Big Dipper. You find the handle, and you can see that the handle makes somewhat of an arc. And if you follow that arc, you're going to arc to the star Arcturus, which is a very bright star, magnitude 0, and it's reddish in color, and it scintillates, it kind of glows, changes colors. It's really kind of a neat star. So find the Big Dipper's handle, you're going to arc to Arcturus, and then you're going to spike down to Spica. Spica is this star here, and it may look a little whitish blue. That's because it is, in fact, whitish blue. It's a magnitude 1 star, so it's about 2.5 times dimmer than Arcturus, but it's still plenty bright. Arcturus is in the constellation of Boötes. The star Spica is in the constellation of Virgo the Virgin or Virgo the Maiden. And then I love this little constellation. You see down here, it kind of looks like a kite. You got 3 stars and then 1 star down here. I have to bend over to point to it. That's just kind of a neat constellation called Corvus. It's the crow or the raven, kind of a neat constellation. So I want to put up the constellation lines because I want to point out a couple of other things with you. So again, we're arcing to Arcturus, and if you look at the stars going up, to me, it kind of makes like an ice cream cone. Would you not agree? You get a little bit of an ice cream cone going on here. From Arcturus up, you get the cherry on top, and look over here. It looks like a dollop of whipped cream has fallen off, right? You see this? And that is actually like a tiara, or it actually is Corona Borealis, the northern crown that you see right here. So there's another constellation for you. Corona Borealis, the northern crown. And then as you come over to Arcturus, you spike down to Spica. This is the constellation of Virgo. And if we put up the next slide that has the imagery, the artwork, you can kind of see Virgo, the Virgin here, where you have Spica representing an ear of corn, sometimes a sheaf of wheat, sometimes it's a ring on her left hand, and you can see the crow down yonder. And sometimes people ask, well, what is that big guy that has the snake? Well, that's Ophiuchus. He is the 13th member of the zodiac, Ophiuchus. He's the serpent bearer, and here we have serpens caput, which is the head, and then we have serpens cauda, which is the tail of the serpent. And then next time we'll talk a little more about Hercules. There's some great star cluster that you can find in the constellation of Hercules. Kind of looks like it makes a little bit of an H. We'll talk a little bit more about Hercules next month. This next slide, we kind of getting back to the stars without the lines, without, can you find your way around? That's important. Big Dipper is up above. Remember, arc to Arcturus, spike down to Spica. And then this kite-looking thing, that's the crow Corvus. Let's go to the morning sky. With Adam, we already talked about the moon slithering by all these planets. The picture we saw earlier was May 25th. This is May 29th. And what I want to point out to you is look at Mars and Jupiter. You almost really can't read the names Mars and Jupiter because they're so much on top of each other. They are 0.6 of a degree away from each other, just about the width of a full moon apart. That's going to be a great morning, and the morning of May 28th, 29th, 30th are all going to be great. Get your binoculars. A telescope will be awesome. Venus is still blazing. We talked about Saturn rising first, right up here, and you want to enjoy the planets in the morning sky. This is about 4:15 in the morning, when just before things start to get too light. So that's kind of what you have to look forward to in May. I hope that you enjoyed the show, and remember to keep looking up. I'm Dave McDonald for The Sky This Month.